Now take down a problem based on motional EMF. A 0.5 meter long metal rod PQ completes the circuit as shown in the figure. The area of the circuit is perpendicular to the magnetic field. The area of the circuit is perpendicular to the magnetic field. The area of the circuit is perpendicular to the magnetic field of flux density .15 Tesla. If the resistance of the total circuit is 3 ohm, if the resistance of the total circuit is 3 ohm, calculate the force needed to move the rod. Calculate the force needed to move the rod in the direction as indicated with a constant speed of 2 meter per second. Okay. A 0.5 meter long metal rod PQ completes the circuit as shown in the figure. The area of the circuit is perpendicular to the magnetic field of flux density 0.15 Tesla. That is, the area and the magnetic field are perpendicular to each other, the area of the circuit. If the resistance of the total circuit is 3 ohm, or I can say that the flux is, or the field is perpendicular to the plane of the coil. Calculate the force needed to move the rod in the direction as indicated with a constant speed of 2 meter per second. Now the figure you take down first. Now I'll show the resistance as concentrated at this point, and then the rod PQ is given like this, and it is moved in this direction. Cross magnetic field, and the field appears as though it is going into the plane of the paper. So it is perpendicular to the magnetic the area of the circuit is perpendicular to the magnetic field, or magnetic field is perpendicular to the area. Now we need to find out what is the force required in this case, so that the PQ you can move with a velocity of 2 meter per second. First list out the given quantities. You are given with the flux density, that is B, as 0.15 Tesla, and then length of the rod L is 0.5 meter. What else is given? The resistance is given 3 ohm, and velocity is also given 2 meter per second. Now you have to calculate what is the force required for this moment. You know the formula, F is BIL. F is BIL. We have done the derivation also. F is BIL sin theta. Theta is 90 degree here, so sin 90 becomes 1. So in simple, I can say that F is BIL or IBL. We know B, we know L, but we don't know I. How do we calculate I in this case? This is the motional EMF. So I is E by R, which is BLV, because motional EMF is given by BLV divided by R. Now substitute this value of I in the force equation. Therefore F is equal to B into BLV divided by R into L, or this will become B square L square V divided by R. B square L square V by R, or you can, in simple, you can write it as the force required as BL whole square into V divided by R. Now we substitute the quantities one by one. The given field is 0.15 and length of the rod is 0.5 whole square, and velocity is 2 meter per second, and the resistance is 3. Now do this calculation and write the magnitude of this force. What is the force required? Yes, you will get it as around 3.75 into 10 to the power minus 3. And what is the unit of force? Newtons. F is 3.75 into 10 to the power minus 3 Newton. Remember the formula for the force, F is BIL. So you can write the force needed to move the rod in the direction indicated is given by 3.75 into 10 to the power minus 3 Newton. The force needed to move the rod with a constant speed of constant speed of 2 meter per second as 3.75 into 10 to the power minus 3 Newton. This is the force required. So it's given by BIL and I is E by R, and here E is motional EMF BLV.